Alright, so we're done with frequency distributions now. Time to talk measures of central tendency. And the natural place to start is with the mean. Now the mean, as you already may know, is the calculated average value in a set of numbers. And it's calculated by dividing the sum of all the values by the count of all the observations, meaning that it can only be applied to numerical variables. Now let's look at a quick example here. Let's say that we wanted to know the average undergrad grade for our MBA students. Well, we could just take the sum of the grades and divide it by the number of students, which would get us a total of 74.73. Now, quick pro tip, use the average ifs function if you want to calculate the mean for values that meet a specified criteria. So say you wanted to calculate that same average undergrad grade, but broken down by the undergrad degree. And we'll see examples of that along the course and in a few seconds. But before we move on, let's talk about what the big deal is about the mean or the average. Why is it used all over the place? And the reason for that is that it typically represents a best guess about the value of a randomly selected observation from a variable. In other words, if I grab one of these students at random and asked you to tell me what his undergrad grade was, well, then 74.3 would be your best bet, which is pretty cool, right? But there are some limitations to the mean. The main one being that it is sensitive to outliers or extreme values. And a good way to think of it is that the average income in America is not the income of the average American. Now that is intuitive in itself, but let me illustrate it further with an example that you'll likely see all over the place if you're, reading other stats books or taking other courses. Let's say that Molly, Mike, and Mindy are sitting at a bar together and they make $35,000, $50,000, and $65,000 a year, respectively. Well, if you grab the mean of those salaries, you get $50,000, which is a pretty representative number or guess about the salary of any one of those people. But now imagine that Bill Gates walks in and sits next to them at the bar. Well, he makes, and I think this is actually much less than the real number, $100 million a year. Well, that outlier just caused the mean of the people at the bar to go up to 25 million, which makes no sense whatsoever. I mean, 75% of the people sitting there probably won't make that much in their lifetime. And that's the key takeaway here. While the mean is typically great for making a best guess estimate of a value, it is important to complement this value with other descriptive statistics like the distribution, the median, and the mode to see if the mean value is being distorted by outliers. And if it is, you can at least be aware of it, or you can remove those outliers to obtain a better estimate. But now that we're here, let's take a look at the median and the mode, shall we? Now, whereas the mean is the average value, the median is the literal middle value in a sorted set of numbers. It's the income of that average American. And because of this, the median is not sensitive to outliers. So if we wanted to calculate the median for the undergrad grade, well, we could just sort these numbers and grab the one in the middle, and we're good to go. Or we can, of course, just use the Excel function for it instead, which we will in a minute. But when there are two middle ranked values, then the median is going to be the average of the two. So if we take away one of these students so that we only have 16, well, then the median is going to be 74.3, which is really just the average of 74 and 74.6. And keep in mind that even if we change that 63.3 at the top to a 0, making it an outlier, the median would actually stay exactly the same, but the average would change and would actually drop in value. And finally, we have the mode, which is the ugly duckling of the bunch. Now, the mode is simply the most frequent value in a variable, which makes it applicable to both numerical and to categorical variables. So if we get the mode for the undergrad degree, well then it would be business since it's the most frequent. And if we got the mode grade, well then we'd get NA. But that's only because each value in this sample that we have here only occurs once, but don't worry. Say we had 78.9, which is the top value, be repeated somewhere else, well then that would be the mode. But I did this because it brings me to my next topic, which is the modal class. And the modal class is the group with the highest frequency. So say that we took the grouped frequency table for that same variable, then these two bins would be the mode, from 65 to 70 and from 75 to 80. And this is actually known as a multimodal distribution, or a bimodal distribution in this case, since we have two modes. And visually, you can think of it as a histogram that shows two or more separate humps. Now, I'm not going to go into it in depth here, but a multimodal distribution is usually a good indicator that there may be another variable that's impacting those numbers that you're visualizing. For example, human heights are a bimodal distribution, since gender is a big part of height. So if you were visualizing the distribution of human heights, you'd see a peak with the most frequent female heights are, and you'd see another peak separately where the most frequent male heights are. So typically you'd want to filter or split those heights up by that second variable, which in that case would be gender. But that's the mean, median, and mode. So now let's quickly jump into Excel so that I can show you their equivalent function and some different use cases for them. All right, here in Excel, let's quickly jump to the mean, median, and mode link and calculate these measures of central tendency for our annual salary variable. So for the mean, we have the average function. We just select our range, enter, and there we go. For the median, we have the median function. And for the mode, we have three separate functions. Actually, you can use the legacy mode function, which is available from Excel 2007 earlier, or you can choose between the single and multiple. I'm going to use single right now and focus on multiple once we're in the dynamic array formula section here, just because that is going to spill the different modes in case there are any. So I'm going to stick with mode single, select my values, and we get our mode. So what does this tell us? What is the average salary for our current graduates? Well, the mean is $119,000, but the median and mode are much lower than that. They're around $15,000 lower, in fact. So what that tells us is that there are likely some very high annual salary values here, some outliers, that are causing our mean to be higher than the median and the mode. And we actually know this, if we go back to our histograms tab, when we visualized it. These are the outliers that are causing our mean value to increase. So let's go back to our mean, median, and mode tab. And we've answered the first question now. But what about the second one? Does the annual salary vary by work experience? Because we could very much think that people with previous work experience are getting higher annual salaries than those that don't. So let's run those numbers. Let's go here. Let's calculate the average salary for people with work experience. And for that, if you remember the pro tip, we're going to use the average ifs function. So for the average range, we want the values that we want to calculate the average for, in this case our salaries. The criteria range is the values that we want to use to filter these annual salaries, in this case the work experience. And the criteria is the value for the work experience that we want to filter the annual salaries by, in this case when work experience is yes. And before I close my formula, I'm actually going to fix these references with F4, fix this one as well so these don't move, and I'm going to leave this one as relative so I can move it over to the right. Close that, move this over, and if I press F2, you'll see that we still have these two, and now we're pointing at no. So we've got the average annual salary for yes as work experience and for no as work experience. Now for the median and the mode, it gets a little bit trickier because there are no median ifs or mode ifs functions. So we are going to have to get a little creative here. We are going to start with the median function, But then we're going to add the if function ourselves. So if the work experience is equal to yes, and again I'm going to fix this reference here, then in my value if true, I'm going to return the range that I want to return the median for, which is the annual salary. Select that, F4 to fix it, close the if function, close the median function, and if you don't have Excel 365, don't press enter yet. You actually want to press Control-Shift-Enter. And what that's going to do is add these brackets around the function, which are necessary in this case since this is technically an array function. It's not a dynamic array function, which is why you can do it before Excel 365, but it is considered an array function. So if we drag this to the right, we get the results for the median average salary with no work experience. And if I copy all of this, let's paste it here, and let's change median to mode, mode single, Control-Shift-Enter, drag to the right, and there we go. Now for dynamic Excel, the average ifs function is going to work the same way. We're going to use average ifs. We've got our average range. We've got our criteria range. And for our criteria, instead of selecting them individually, we can select both. Close that, and the results are going to spill, but you'll see that we get the same exact ones. And for the median and the mode, we can use this same approach here. Or we can use the median function and the filter function to filter our annual salary array so that it only includes the values where work experience is equal to this right here. Close filter, close median. Let's fix these two. Press enter. We get this same value. Apply it to the right, and we get this same value as well. And again, let's just copy this, paste it here for the mode. And in this case, let's try the mode multiple function. And when I press enter, you'll see that the annual salary for students with no work experience actually does have multiple modes. It actually has 4. If we drag this to the right, you'll see that there's just a single mode for annual salaries for students with no work experience. So, to answer the question, does the average salary vary by work experience? Well, there doesn't appear to be much variation. I mean, some in the mean, but not really in the median and the mode. But this is something that we'll be able to test later to see if there's a statistically significant difference between the mean of people with work experience and the mean of people without work experience. But let's not get ahead of ourselves. Now, this was a little on the longer side for a lecture so far, but hopefully you're now both comfortable in calculating these measures of central tendency in Excel under different scenarios, and now know how to use them to complement each other and interpret the results. Okay, time to talk about the final measure of central tendency, which is the skew. Now, the skew represents the asymmetry of a distribution around its mean. So it's a single value that tells you if the mean really is at the center of the distribution. And in case it isn't, it gives you some indication of how the data is actually distributed around it. So in a zero skewed distribution, the mean and the median are equal, which means that the average value happens to be the middle value as well, which, as you can see from the histogram here, also happens to be inside the modal class or the highest bar. Now, in a right skewed or positive distribution, then the mean is typically greater than the median. Now, from the histogram, the name is a little bit counterintuitive since it almost looks like it's leaning to the left, but the right skew comes from the mean skewing to the right or being pulled to the right relative to the center of the distribution by the presence of that tail of outliers that we can see on the right. And inversely, a left skewed distribution or negative distribution has a mean that is typically smaller than the median, as we can see in the histogram here. Now, zero skew or symmetry around the mean is one of the properties of the normal distribution, which we'll dive into soon enough, but that is the main reason that I'm introducing this concept. But for now, let's just jump to Excel to quickly go over the skew function. Alright, here in the Excel statistics workbook, let's quickly jump to the skew link right here. And we've got the same annual salary variable that we just calculated the mean, median, and the mode for. But now we specifically want to answer the question of whether the salaries are centered around the mean or not. Well, we can use the skew function for that. So let's type our skew function here. Select our data, close it, press enter, and we get a value of 2.93, which is a positive number, meaning that it is a right skewed or positive distribution. In other words, we have outliers to the right side of this distribution, so we have very high annual salaries relative to the center that are skewing the mean. And we had already figured as much just by looking at the difference between the mean and the median in the previous lecture. Now, I personally don't really use this function that much. I prefer to visualize the distribution using a histogram and then identify the symmetry or asymmetry that way. But that's skew for you. Alright, I hope you're feeling good about the measures of central tendency because it's time for an assignment. Molly Mean just got back to us and says, "Thank you for visualizing those grades for me. It was interesting to see that not many students scored above 90. So I do wonder if, since this is a master's in business administration, business undergrads tend to do better than others." Alright, that's a good question. Could you give me a quick summary that shows the average MBA grades for business undergrads versus other undergrads? And I'd appreciate it if you could interpret the result for me as well. Awesome. So we've only got one key objective this time, which is to calculate the mean, median, mode, and skew for the MBA grade variable by undergrad degree. Now I'll leave you to it, and I will see you in the solution video once you give it a shot.